So let's move on to the scenarios now. The first one that I'd like to show you is the scenario of catchment areas, which I think Aaron referred to earlier. So the first scenario I have shows a few capabilities of FME beyond simply integration. It does involve some data prep and spatial analysis. It's really your choice what tools you use for those processes. For example, we're not trying to replace a GIS application or an analytics engine. Our main goal is really to help you get the data wherever you need it. If that means performing automation or performing some spatial analysis as well, then we're happy to help you move the data, that final step, if our tool is up for the job. And that's kind of what I'm going to show here. And this goes for your BI tool of choice as well. So as you can see here, I'll be showing Qlik in the following demos. But we can also integrate with Tableau, Power BI, Looker, and others. It all boils down to using FME to get the data where you want it. So yeah, let's look at this example of catchment areas using FME and Qlik. So this example was built using New York State Open Data, and it displays continuous driving time distances in minutes from all locations in this area of interest to the nearest medical clinic. Driving times are indicated in minutes. And since I've enriched the underlying data with demographics from the US Census Bureau, I can actually drill down and look at information about population and healthcare coverage for a given area. So red here is actually a very short driving time. So right in the downtown sort of core here of Syracuse, it's only a few minutes to the nearest clinic, and you can see how many, sort of what the density of clinics is in this area. If we move out, we notice some kind of cool spots where it's a half an hour-ish or more to get to a clinic, and I can drill down to this area as well, and I'm given some data from our demographic enriched data just concerning household income, population without health insurance, and the possibilities here are endless as well, just up to the data you have. So I think for this kind of visualization, the spatial relationships between the data unlock more insights than traditional joins might alone. Visually, we're able to make brand new associations and insights based on location alone. Underpinning this map and dashboard is a simple data integration and analysis question that we can tackle in FME. So at any given location, how long do I have to drive to get to the nearest clinic? And the insights that come after that answer another question. Where do we need more clinics or more outreach? So you can imagine the types of data sets needed to accomplish this and the integration as well. For instance, with traffic data, road infrastructure data, clinic location data, demographics, point of interest data. In FME, we can integrate and blend these, and even in some cases procure these, such as through open data portals or APIs like the US Census Bureau API. So as far as FME is concerned, a few steps were required to reach this end visualization. The first steps were to gather, integrate, and validate the raw data. So I'll jump over to an FME workspace and just at a high level kind of explain this process. So we gathered the data sets. This include clinics, points of interest, which happen to be in the CSV. We also grabbed a road network for New York State. This is also open data, and I have it in a spatial database. So in this workflow, I'm really validating the connectivity of this road network. I need to know that all my road segments connect. I need to do a little bit of calculation to find out how long it takes to travel along each segment of road. This is based on the length of road, as well as the speed limit noted for that road, as well as a little bit of extra just to sort of make it a real world. You're not always traveling at the speed limit necessarily. And then we also need to kind of match that with the clinic data. We need to make sure our clinics are snapped to that network to be able to perform our analysis. So this is really the validation, cleaning the data, making sure it all lines up so we can move along to the next step. The next step is building something useful out of this raw data. So we're going to integrate these raw inputs that are now validated into something useful, forming relationships between the data sets and building a final data set that can be actually visualized in the end. So we're in this workspace reading both of those input data sets again, but now cleaned and validated. We're merging them to find out the network relationships and finding the cost for each travel time from each location to each nearest clinic. And then we're going to build a model of points for each location in our area of interest, which hold that information of how far is it from here to the nearest clinic. Finally, we'll enrich this data set with our demographic data and actually form a visual output. This is actually split off into another separate workspace, which I can show here, where our input is this rather large data set, which looks like a line network here in our visual preview, but it's really a lot of points which hold that information of how far is it to the nearest clinic. We're going to do a little bit of intermediary raster interpolation here to make that continuous. We're going to generate our drive time areas so that we can actually make a useful visual case out of this. So now we have polygons rather than a combination of points or a raster image. We'll streamline that, enrich it, and output to QVX formats, which in this case just feed into Qlik really easily. This could be a TDE for Tableau, could be Excel or something similar for Power BI. It really just depends on your tool. I've used Qlik for this demo. So that's a catchment area kind of scenario. The next scenario I want to kind of fly through at a high level is related to the real-time use case that Aaron highlighted earlier. So here we got another dashboard. This is just showing current locations of vehicles in the field. It could be really any vehicle or any asset. In this case, it's buses in the Portland transit system. So for this dashboard, FME Server is going to shine a little bit even more than FME Desktop. The data input for this dashboard is actually FME Server streaming data back to Qlik. So if I went to my data source for this, you would actually just see a URL from FME Server, and I'll show you how this works from the FME Server standpoint as well. So let's jump over to FME Server. I'm in the Run Workspace tool, and I can just see that in my repository I've got a workspace called Portland Transit. So this is the workspace that feeds that dashboard. I can actually view it here in FME Server. It's fairly simple. I'm connecting to the Portland Transit API. I'm getting current locations of buses, doing a little bit of JSON transformation, and creating points and setting their real-world location. After this, I'm writing to QVX, but through the power of FME Server, I have created a URL, essentially a webhook, so that when I put this URL into the data source for Qlik, it tells Qlik that every time I'm going to load that source into my BI dashboard, it's going to run this workspace in FME Server and get the latest data. So here's my current dashboard. If I go over to my Qlik management console, I can actually refresh this dashboard, and hopefully we'll see those points kind of move and come back to life. So if I reload this dashboard, FME Server is running that workspace in the background, and it's just streamed back the most current location for those buses in Portland. So from the Qlik standpoint, we can set this to run on a schedule, or we can reload it manually. This turns into a near real-time location dashboard. So the final demo I have for you here is more of a binning scenario or a binning exercise. It's also a heavy spatial component. And this dashboard is looking at sort of how many crimes happen in each neighborhood in Portland. It's more of a traditional data integration workflow. So this dashboard just contains information about the kinds of crimes and total crimes per neighborhood, as well as a little bit of demographic information. Just an example of the kind of dashboard you create for this data set. And from the FME side, I'll walk you through that integration process. So this is a workspace that combines neighborhood areas, demographic data, and location-based crime information into sort of a usable format that we're going to output to QVX for rapid development of that spatial Qlik dashboard. Our sources here are GeoJSON and a Postgres non-spatial. So we've got kind of in that intro, similar to that intro, we've got kind of neighborhood areas, and we've also got demographic data. These are related, so I'm going to join them based on a shared key. So at the end of this transformer, I've got my neighborhoods with their demographic data associated. I have crime data for the whole state of Portland, but I'm only interested in a certain area. So I'm going to feed all of these areas into my crime data reader, which I've got in this bookmark here. So I'm just going to read the points of data for crimes that I'm interested in, just in this area. So here you can see about 50,000 reports of crime throughout Portland. The next transformer is kind of the crux of this workspace, and it's a spatial one. It's the point on area overlayer. It's really just answering the question, what crime reports fall into which neighborhoods? And the answer is going to come out in this area data set. So now for each data set, after FME has related points inside their areas, I now have information concerning demographics as well as what kinds of crimes happened in each neighborhood. So I've got offenses, and I can see, for instance, how many offenses happened in the neighborhood for this given time. The final step here is to sort of clean and aggregate that data so that I have lists such as how many motor vehicle thefts happened in this particular neighborhood. So now I can start to gain some insights from all of this integration work I've done up to this point. And we output to QVX so that literally we can just drag and drop that data set into Qlik and build this quick dashboard.